So let's actually take a look here at example 1. See what this scenario here is all about. Suppose that there's a company that produces colored chips. Okay, so this isn't a very thrilling problem, but let's suppose that there's a company, they produce chips, maybe like poker chips or something like that. And these chips are machine produced, and the machine is designed to randomly assign half of the items, half of these chips to be red and the other half to be blue. So you can imagine, right, that I have these, blue chips, maybe over here. I have red chips that are being made, and a machine kind of, makes an arbitrary chip, maybe, one that's like this, and then you can imagine that it decides randomly which one it's going to produce, right? It's either going to maybe like spray this thing into blue or spray it and make it red. Okay, so suppose that, you're in charge of quality control at the company plant, and maybe one of your jobs is to check to see every so often if this machine is working properly, right? Because if you need to make, half the chips red and half the chips blue, it would be really bad if all of a sudden, for like 2 months, only blue chips were being made. Something like that could be a really bad thing. So maybe you decide to check the last 100,000 chips made by the machine. Maybe that's like everything produced in the last week or the last day or something like that. And you want to actually see again if the machine produced half red and half blue chips. Well, of course, there are a couple ways to do this, right? You could dump out all 100,000 chips on your desk in front of you. You could imagine what a mess that would make. And you could start sorting them into piles, right? Put all the blues on one side, all the reds on the other. And then you could individually count them, right? And if the machine was supposed to produce half and half, then you should have 50,000 red chips and 50,000 blue chips. Now, I don't know about you, but there is no way that that is a task that I would be interested in completing. Um, Even if I had like 1,000 items that I was going to have to split into two groups, like, and then count things up as how many of each I had, that would be a lot. But 100,000 chips? That's just getting like ridiculously large. So maybe instead of looking at all the chips, maybe we can take a small little group. So maybe we take a random group of 16 chips, right? So you can imagine maybe all these chips here are sitting in some sort of a bin, right? And inside there you got some blue chips floating around, and you got some red chips, right? And maybe in this whole bin are all 100,000, and it's supposed to be 50-50 if the machine's working correctly, right? It's supposed to be half and half. So you reach your hand in, right, and you maybe try to grab a handful of chips, right? Like you grab 16. So you jump in, you grab 16 chips, you pull them out, and you find, very surprisingly maybe, that 15 of the objects that you pulled, 15 of those chips, are red. So can you determine anything from this? Notice this is exactly what we had talked about in the examples up above, that we want to learn something about all 100,000 chips, and we're going to see if we can make an educated guess about what's happening with all 100,000 by only looking at a few of the chips, that is 16 of them. So let's see how this would work. But first, let's answer a couple basic questions. Now, obviously, you're not going to be able to tell me the answers to these questions to write them down, but I am still going to ask you to think through them. And as you think through these, one of the biggest important things that you have to understand is that when I ask you these questions, you need to treat them like this is not a math class. Don't think about this like there's some fancy math answer. Just think about it like you were talking to your friend about this, right? Or you're talking to your, a family member, right? I don't know why you would be talking about chips like this, but let's just suppose. So take a look at part A. Does the fact that you found 15 out of 16 items colored red mean that the machine produced more red chips than blue chips in the total 100,000 items? Think about that for a moment. You pulled 15 chips out of the 16 being red. Does that mean that all of the chips in the bin, there are more red chips than blue chips? Does that mean that guaranteed 100% certainty? Well, I think the answer here would definitely be a resounding no. It doesn't suggest that. It might suggest that. It's possible that there's more red chips in the bin. It's possible there's more blue chips in the bin. Did we look at all the chips yet? Not at all. So notice I can just quickly say here, we haven't looked at all of the chips, so we don't know how many are red, how many are red, and how many are blue. We don't really know, right? We could probably come up, though, with a couple different ways to maybe explain away why we got 15 red chips out of 16 chips that we pulled. Let's think about that. This is part B. What are some hypotheses that can explain why we saw 15 out of 16 chips colored red? Okay, well, here's one explanation that we're always going to have. This hypothesis 1, we're always pretty much going to be attributing that to something dealing with luck. So take a look at how I'm going to word this here. I'm going to say that in hypothesis 1, the machine is working, and thus half of the 100,000 chips are red, and the other half are blue. Okay? So this is part of our hypothesis. It's not complete yet, but we're going to start with what we think is happening with the machine. So one way we could explain why we got 15 out of 16 chips being red is that the machine was working perfectly. There are half blue chips in the bin, there are half red chips in the bin, and we just got a, I'll put this in quotes here, but like we got a lucky pull of 15 red chips, right? Like there's nothing fancy going on here. We just kind of got lucky. And sometimes that happens, right? Like, I mean, I don't know if you've ever, played a board game before, or played cards, or I don't know, played the lottery. There's could be a lot of things that could have happened. Maybe you play sports and you try to do some, like weird basketball shot where you bounce the ball off the ground and try to see if you can get it in the hoop, or bounce it off a wall, or right. But like sometimes people just get lucky. Sometimes you can roll a die and roll like, I don't know, like 6 sixes in a row. It can happen. Sometimes you can make a ridiculous trick shot in basketball. Weird things can occur. Maybe this is just a weird thing. Maybe we just got lucky. That's a possible explanation. However, it's not the only explanation. We could also say something like, the machine isn't working correctly, and it produces more red chips than blue chips. Notice, doesn't this begin to possibly explain why we got more reds? If there were more red chips produced by the machine, that is, there are more red chips in the bin, then it wouldn't be as surprising to make a pull that got us 15 red chips out of 16. So I'll say here, the fact that we selected 15 out of 16 chips as red is evidence of this. Notice both of these hypotheses make sense. We don't know which one is correct. Either could really be correct. Let's take a look at part C then. Since you are in charge of quality control, you would actually need to check to see if the machine is operating as intended. So is there a way that we could test whether or not the machine is actually working correctly? And of course, what we'd like to do is to figure out, essentially, can I decide which of these hypotheses I think is the correct hypothesis to go with, even though I haven't looked at all the chips yet? Well, there are a lot of different ways that I might be able to come up with trying to ultimately, I guess, simulate the idea of picking chips out of this bin. I'll write something like this. I'll say, if the machine produces half red and half blue chips, if it's like working correctly and it actually produces half red and half blue chips, then there should be a, 50-50 chance of any chip being red or blue, right? Like, if I want to count red chips, there's a 50-50 chance that a chip that I pull should be red. There's a 50-50 chance that I could pull a chip that's blue. So our question would be, how weird is it, if the machine's working correctly, how weird is it to get 15 chips that are red? How hard is it to get this lucky? Is luck a good explanation? What we're actually going to be doing here is putting to the test hypothesis 1. I often kind of imagine it as like, I'm going to try hypothesis 1 on, like I'd try on an article of clothing. And if it fits well, then I'll keep it. But if it doesn't fit well, then I'm going to ditch it and I'm going to go for another thing that fits better, which would be hypothesis 2. But to test hypothesis 1, we need to actually see how easy or how hard is it to get this lucky. And one thing that we could actually do here to kind of simulate getting a 50-50 chance of something happening is maybe by flipping a coin. So I could say that we could simulate the selection of 16 chips via coin flipping. Okay, so we've set the stage here for how example 1 is going to play out. How do we answer these big questions using some small set of data to help us? Now, in the next video, you'll see how we'll actually go ahead and do this simulation, and we'll finish off the rest of example number 1.